Hi everyone, welcome back to the channel. I'm Peter. Today I'm going to show you a few tips to secure an SSH server on Linux. I'll be using AlmaLinux for this demo. Alright, let's get started. Tip number 1. Change the default SSH port. By default, SSH listens on port 22. So let's change that default port to, for our demo purpose, we'll change it to port 2222. Changing this port won't make your server unbreakable, but it does significantly reduce random login attempts and automated bot attacks. And to change the port number, go to the SSH configuration file, look for the word yes. By default port number it is 22. Let's change it to 2222. On AlmaLinux and other real-based systems, changing the SSH port involves 3 steps. The first one is updating the SSH configuration file, which we just did, and the second part is to allow the new port in the firewall. Let's check if firewall is enabled and is started. Yes, it's enabled and it's started. Yes. Now let's see if firewall allows port 2222. No. So you'll have to add the custom port to firewall D. The command is firewall cmd add port. The port number is 4 times /tcp, and let's use the permanent option so that it is boot resistant, meaning after your server is restarted the rule should be persistent. Okay, now let me reload the firewall rules. Okay, good. And the third step of this first part is to add the SE Linux port context. Let's use this command to search for SSH SE Linux port. As you can see, this is the SE Linux port context. Here only port number 22 is allowed, so let's add our custom port number. The command is se manage port -a-t. The context is SSH port -t, and we need to add protocol -p, which is TCP, and the port number is our custom port number 4 times. Okay, let's run this command again. Okay, as you can see here, our custom port number is added. Now let's restart our SSH service. Okay, I'll log out. Okay, now let me try to log in again. As I've mentioned before, the default port number is 22, so if you don't specify any port number, it will try to use the default port number, which is 22, and it should fail. Okay, as you can see here, connect to host server port 22, connection refused. Why? Because now SSH is not listening on port number 22, but rather it's listening on 2222. Now let's try to run again with port number 2222. Okay, it's asking for my root password. I'll just type in the root password. Looks good. Now I'm able to log in with the default port. So tip number 1 is done. Tip number 2, disable root login. By default, every Linux system has a root user with full privileges. Allowing root to log in via SSH increases the attack surface significantly. As a best practice, it is safer to log in using a regular user account and then elevate privileges with sudo when necessary. Let's disable root login. Let's change the SSH configuration file again. and look for the word permit root. Yes, this is the one. As we can see here, it's the value is yes. Now let's change it to no. So this will disable my root account to log in by SSH. Let me restart the SSH service again, log out again. Now let me try to log in again with my root account. Okay, it's asking for password. Let me type in the password. Even when I typed in the correct password, it fails. Okay. As we can see here, I'm not able to log in. Tip number 3. Enable key-based authentication only and disable password authentication. Passwords can be guessed or brute force, whereas SSH keys are extremely difficult to compromise. We can achieve pub key authentication or public key authentication by editing the SSH configuration. Go to the same configuration file and look for pub key. Yes, we can see here public key authentication should be yes, and key based key sorry password authentication should be no. Before we starting the SSH server, let me go to my client VM and let me try to copy the key of Peter account so that I don't get locked out. The command is SSH copy ID, port number, the custom port number, and the account, and then the VM or the server. Since I've already generated key, I'll not be running this command again. This SSH keygen will generate a key for you, which you can copy it to your SSH server. So I'll skip that step. Now, okay, type in my the Peter account's password. Okay, I've already added my key. Now I should be able to log in without typing in password. -p 222. Okay, it looks good. Now let me start the SSH service. I've just restarted it. I'm able to log in because I've already copied my public key. Let's check. We have 3 accounts here: root, Peter, and student. Students key is not copied to the SSH server, so when I try to log in with student account, it should fail because I've not copied my key to the SSH server. Now the password, I just type in the password. Oh, sorry. It should fail, but it's not failing. Let me check. Password authentication is yes. Even though I've made password authentication as yes, my global configuration, sorry. Mm, yes, actually it should be password authentication should be no, sorry. I thought I have already entered it. Password authentication should be no. My bad. Okay, let me restart SSH service and let me check if, okay, we can confirm that password authentication is now no. So I've restarted the service. Let me log out again and let me try to log in with student accounts, which should fail. Okay, I'm denied outright. So what it means, we're not able to log in with password authentication, but we can only log in with the key-based authentication. Tip number 4, allow only specific users to log in. To test this scenario, let's make changes to our configuration file and add allow user. Actually, I've not added. Let me go to the last line. Allow users. Let's allow only students and let's block all other users. SSHD. Let's restart. Previously, I was able to log in with Peter account. Now let me try to log in again. So I'm not able to log in. Why? Because the account Peter is not in the allow users list. This is very simple but very effective. It means it will limit which users can log in through SSH. This also reduces exposure and ensures that only authorized users access the server. Now let me just, for demo purpose, sorry, let me move a little bit this side. Okay, now let me allow Peter. Let's restart it. Let me try to log in again with Peter account. I should be able to log in now. Looks good. And the fifth tip is to set an SSH idle timeout. If a user logs in and forgets to log out, the session remains open. To protect against this, we set an auto timeout. Let's edit the SSH configuration file again. Go for the directive client alive. As we can see here, by default it is 0, which means it's not going to check. Let's change the value to client alive interval value to 300, which means 300 seconds or 5 minutes. Client alive count max 2, which means we try to. Okay, I'm going to explain a little bit in detail. Okay, these are the two values I just edited. It means every 300 seconds or 5 minutes, the SSH server sends a small "Are you there? Are you still there?" message to the client. It checks whether the connection is still alive. And count max 2, it means if the server does not get a response from the client, it will retry 2 times. If the client still doesn't respond, the SSH session is automatically disconnected. So the SSH session will disconnect after 10 minutes of no response from the client. It is useful, especially on multi-user systems. And that is it. 5 simple and essential ways to secure your SSH server. These are some of the simplest methods to harden your SSH setup. There are definitely many more advanced techniques, and these tips are not the only ones you should rely on. If you found this video helpful, give it a like and share it with your fellow Linux admins. Thank you for watching, and I'll see you in the next video. Bye.